Here are our basic inverse trig functions. How do we use those to graph other inverse trig functions? So you should identify any horizontal or vertical shifts. Based on adding or subtracting, we should identify any horizontal vertical stretches, expansions, or flexions. Stretches and expansions are the same. This should be stretches and compressions. And transform the original inverse trig function. So our original inverse trig function goes from pi over 2 down to negative pi over 2. And it looks generally like this. We have no horizontal shift. We have no vertical shift. We have an amplitude. It's not really an amplitude, but we have a vertical expansion. So let's begin. That's not what I want. I want an x-axis and a y-axis. And if my amplitude is 3, we're multiplying each of these asymptotes by 3. So what started at pi over 2 will now be at 3 pi over 2. So I'm going to draw this as 3 pi over 2, and then the same in the negative y direction, so negative 3 pi over 2. This distance was halfway between 0, 0, between the x-axis and pi over 2. So in this case, that would be 3 pi over 4 is the y-coordinate. Because it has not been expanded left-right at all, we can still say that it is 1 as our x-coordinate. We have negative 1 as our x-coordinate here, and negative 3 pi over 4 as our y-coordinate. Then all we have to do is connect the dots. And there is our expanded vertically inverse tangent function. Here we have no vertical expansions. We have no horizontal expansion. We just have a shift left 2 and up 4. So let's remind ourselves, what does the original arcsine look like? That is not arcsine. Arcsine goes from here to here. So if we take this, we shift it up 4, left 2, that'll give us our answer. So this original point was 0, 0. So we're going to shift it up 4, left 2, and that's going to become negative 2, comma, positive 4. This original point was 1, comma, pi over 2. And shifting that up, left 2 is going to be at negative 1. But pi over 2 plus 4 is not exact. So we're going to be adding this, pi over 2, and we're adding 4 to shift it up. Common denominator would be 2. So pi over 2 plus 8 over 2, so 8 plus pi over 2. So this is what, about 11, approximately 11 over 2, so 5.5. So this is somewhere around 5.5. 1, 2, 3, 4, 5.5. So it's going to be a little bit above 5.5. And this is negative 1, comma, pi over 2 plus 4. So I needed to figure out what it was approximately in order to graph it on the coordinate plane, but I'm just going to label it by its exact value, pi over 2 plus 4. Same thing happens with our original point of negative 1 comma negative pi over 2. It's being shifted left 1, so at negative 3, and then being shifted up 4, so it's going to be 4 minus pi over 2. And that's going to be about there. That's a little sloppy. There, and there. So we have negative 3, comma, 4 minus pi over 2. And here is our transformed arcsine function.